Okay, so today we're going to learn about solving quadratics. And this is the first kind of day when we're going to talk about solving quadratics and kind of what that means. So the most important thing for quadratics is the arc that it makes, but generally it's like in real life it's this downward arc. And you want to know where the thing starts and where the thing ends. These are called x-intercepts. And if you remember how you find the y-intercept, you make x0, so you find an x-intercept by making y0. So essentially, we're going to take quadratics that look like y equals x squared plus 3x plus 4, and what we're going to try to do is we're going to make y0 and then try to solve for this. Today, we're not going to worry about things that have 3 terms. We're only going to worry about things that have 2 terms. So for these quadratics today, we're only going to worry about things that have 2 terms, or no b term. So we're going to solve stuff that doesn't have a b term. What method we use when it doesn't have a b term is we call this solve by square rooting, and it's the first method we're going to use. You probably have seen this in Algebra 1 or heard of this concept because we do teach this in Algebra 1. But this is the first method we're going to do. I'll show you a couple examples and a couple problems like that, but that's really where we're going to be at, is solve by square rooting. Okay, so we're going to solve this quadratic. Again, we know what y is going to be. Y for us is going to be 0. So we have x squared minus 64 is equal to 0. Well, our first step would be getting this value away. So we're going to add it to both sides. And what we're going to get is we're going to get that x squared is equal to 64. Now, how you get rid of a square term is you take the square root of both sides. And when you take the square root of both sides, you want to put a plus and a minus. And the reason you want to put a plus and a minus is because we have this U shape, and so when you think about it, the U shape should cross in 2 points. It should cross somewhere on the negative side most times and somewhere on the positive side most times. It can be shifted over so both are on the positive like this, or both are in the negative like this, but generally you have one on the negative side and one on the positive side. So when we take the square root, we have to account for the positive side and the negative side. So my answer would be plus or minus 8, or another way of writing this would be 8x or negative 8. That would be your 2 answers. Let's try another one. So we're going to solve this one. So we're going to do the same thing. We're going to subtract 9 on both sides, and we're going to get x squared equals negative 9. Then we're going to take the square root of both sides. And when we take the square root of both sides, this time we have an issue. Oops, I don't need that term. Our issue is if you tried to do the square root of negative 9 on your calculator, it's going to say an invalid input. That's because there is no two numbers that are the same that can multiply together to give you negative 9. So last year, or your Algebra 1 year, you were told to say that's no solution. That's not entirely true. It just has no real solution. So what we're saying with that is there's no real solution for this thing, but there are what we call imaginary solutions. So this is kind of how it works. I can't take the square root of negative 9, but I could take the square root of 9, and then I'm just going to leave this negative 1 out here, because we know that 9 times negative 1 is negative 9. So again, I want this to be plus or minus, and so we get that x is equal to plus or minus 3 radical negative 1. Well, because this negative 1 issue comes up a lot, they have a special name for the square root of negative 1. They call it I. So that's just I. So now what we would have is we'd have x equals plus or minus 3i. And everyone just knows that I is a special kind of variable. It's called a constant. It's like pi. Like, you know how you think pi is 3.14? I just means it's negative 1. But we treat it like a variable. Like, it just works like a variable. Your answer becomes x equals 3i or negative 3i. And i's are really not that complicated. It's just later in problems, if you could square it again, then you could get an answer. So sometimes we just keep them around to keep answers. We'll do another one. So let's say I was given this. Again, my first step is I'm going to subtract 72 from both sides. I'll get 2x squared equals negative 72. Then I'm going to divide both sides by 2. When I divide both sides by 2, I'm going to get x squared is equal to negative 36. Then I'm going to take the square root of both sides. When I take the square root of both sides, I'm going to get that this is equal to x equals plus or minus. And again, we can do the same trick we did last time, where we say, well, this is the square root of 36 and the square root of negative 1. So that would be just 6i, because the square root of 36 is 6, and the square root of negative 1, we just call it I. And that would be our answer. Let's do 2 more problems. Okay, let's say I'm going to solve this one. The first thing that I would do on this problem is I would want to add 24. As some people that try to deal with this squared term first, you just want to leave it. Just leave the squared term as it is. So you add 24. You have 3x minus 10 squared equals 24. Then you're going to divide both sides by 3. That's going to give you x minus 10 equals 8 squared. Now that we have the squared term by itself, we're going to take the square root of both sides. Whoops, put the plus or minus on the wrong side. This is where it gets a little bit tricky because that is plus or minus. So what you end up getting is you end up getting that x minus 10 equals the square root of 8, or x minus 10 equals the square root of negative 8. So you want to make sure that when you do this, you're going to actually end up splitting it into 2 problems. Because again, whenever you take the square root, you're going to get 2 different answers. Well, then we would just go through and solve this. Now, I don't know what the square root of 8 is. You can just leave it as the square root of 8, or what you could do is just get a decimal approximation, which it's 2.8. So we would get that. We'd get that x minus 10 is equal to 2.8, or x minus 10 is equal to negative 2.8. I would add 10 to both sides. And then I'd have x equals 12.8 on this side, or that x is equal to whatever 2.8 negative plus 10 is, which is 7.2. Notice how these are not the same answer, right? Like every single time before, we've had a positive answer and a negative answer. In this situation, we won't have the exact same answer. Let's do one last one. Again, we'll go through and solve this. So my first step would be adding 12 to both sides. I would get that this is 3x minus 4 squared equals 12. I would then divide both sides by 3. And then I would get x minus 4 squared equals 4. Again, we'll take the square root of both sides, and when we take the square root of both sides, we get a plus or minus. So this is going to make two problems. We're going to get x minus 4 equals 2, and we're going to get x minus 4 equals negative 2. I would then add 4 to both sides. This answer would become x equals 6, and this would be x equals 2. Again, you'll notice that they're not the same answer. Anytime you have these parentheses, they shouldn't be the same answer. Anytime you don't have the parentheses, they will be the same answer. Try the different problems today. If you get stuck, just please ask.